As we have seen, a force is acting on a charged particle when it moves in the magnetic field, and that force we call it as magnetic force on the charged particle, or magnetic force on charged particle, or Lorentz force. The force is given, magnetic force is given in the vector form charge into velocity of the particle cross producted with magnetic field, and magnitude of force is equal to QVB sin theta, where theta is the angle between the velocity of the particle and the magnetic field. Before that, we have to see the vector cross product, because this is cross product of velocity vector and magnetic vector. See, if we have a vector CA, this is vector A, this is vector B. Vector A and vector B both are enclosed on a plane. Enclosed on a plane. And the angle between vector A and vector B is equal to theta. Here we will use right hand palm rule. The right hand palm rule is described here. We will explain it later. What is right hand? This is the right hand and this is the palm. And you want to find out what we want to find out, A cross B. A cross B. It means stretch the fingers with the palm facing and align with the A, first one, with A, and move this finger towards B, A to B. And what is the direction? This direction, that is outward direction. Outward direction. This is outward direction. Suppose we have to find out B cross A. B cross A means from B to A we have to move. Right hand with the palm, the stretched finger, then from B we will move B to A, and this will be inward. This will be inward. B cross A will be like this, and this will be inward. See, this is the sign indicate, because this is the magnetic field. Magnetic field, we have to deal with the three-dimensional quantities. In three-dimensional, we can express in two-dimension only on the board, and third dimension, that is in this direction, either going inside or coming out of the plane of the board. That will be indicated with the dot or cross. Dot means it is the direction is from the board coming out, and cross means in the board going in. So now A cross B. Now let us see, from this we can see this is A, and this one, the red one is B. This is A. And we want to know from A to B. A to B, and the angle between them is theta. We want to go from A to B. How we will do it? From A to B, if we are going, we keep the right hand palm like this, and orient in such a way that the finger can be moved. So we are going from A to B in the direction. So the stretched finger is in this direction. So it means if we keep A like this and B, it is in the upward direction. That is, this is A cross B. And B cross A, how we will find out? B cross A. B cross A means the same right hand from B to A. B to A. B to A. This is the stretched direction, and B to A means it is inwards, and if you tilt it B to A, it will be this way. This is B cross A. See, A cross B. See, this is the vector. One vector is here, one vector is here. When we move from this way, it is upward. If we move this way, it is downward. But it means both the ways. This is the vector A cross B or B cross A. It is both are perpendicular to the plane. That is A cross B or B cross A. both vectors direction are perpendicular to the plane containing vector A and vector B. See, either this is the plane in which A and B are contained. Either it will be in this direction perpendicular to the plane and perpendicular either upward or downward, and this perpendicular is, it means that the A cross B is perpendicular to vector A also, and the A cross B is perpendicular to B vector also, and A cross B, direction of A cross B will be perpendicular to A and A vector and perpendicular to B vector. This we have to remember always. It means A cross B means if you are going from A to B in this direction and B to A in this direction inward. This is A cross B, this is B cross A. A cross B is outward and B cross A is inward. So this we have to remember, and this A cross B or B cross A is perpendicular to the plane containing vector A and vector B, and A cross B and B cross A is perpendicular to vector A and perpendicular to vector B. Or we can see A cross B is equal to negative of B cross A, vector product, because A cross B we go this way in this direction and B cross A in this direction, both are opposite to each other. It means the direction of A cross B is opposite to B cross E. This point we have to remember, and this already we have discussed in the vector classes. Same way, similarly we can use the same, because we got dot product, scalar product, that is cross product. So in this cross product, now we have to use this rule. This is one of the rules. This is the almost probably easiest rule we can face. See, F magnetic force is equal to, it's a vector, is equal to charge, it's a scalar, and multiplied by the V cross B. So now here another question comes, the charge may be positive or negative. First we will deal with the positive charge. Q, now we can use for Q V cross B. Suppose if you are moving from V to B, it is outward, or V to B inward. See this, you have to see the direction of magnetic force is along the direction of thumb. If you go this way, the thumb is in this direction. If you go this way, thumb is inside the direction. That's all, the simple explanation. And now we can, for the positive charge, now we will deal with the positive charge. For positive charge, this is very important. Magnetic force is equal to Q into V cross B. It means by right hand palm rule. Right hand palm rule says orient right hand such that the stretched finger, this stretched finger points in the direction of positive charged particle. In the direction of positive charged particle. So this is right hand stretched in the direction of in the positive charge, and move the figure in the direction of B. Stretch the finger point in the direction of for positive charge, in the direction of charged particle, in the direction of charged particle. See, this is the direction of charged particle. So we have to see, that is from V cross B, we have to find out V cross B. So we keep like this, we move from V to B, this direction, that is in this direction, this is V cross B. And for negative charge, and the direction of, now the direction of Fm, because Fm is nothing but cross product of V and B. So if you go from V to B with this hand, right hand palm from V to B, we have to go V to B in this outward direction. Direction of FM is, this is outward direction. This is A cross B, this is outward, this cross means inward direction. V cross B. Now we are talking only for positive charge. Positive charge particle is moving. How about the negative charge? Negative charge, how we will describe? So negative charge means it will be, see, we can say A cross B, see, from the vector product A cross B vector is equal to minus of B cross A. That is, the direction of A cross B is equal to opposite to the B cross A. It means A cross B in this direction means B cross A will be in the downward direction. Very simple, only thing the direction changes, the rest all remains same. Same way, if you use for negative charge, for negative charge, how we will calculate? Second, again we have to go through this all the procedure? No, we need not confuse. Only thing, reverse the direction for this positive charge. Positive charge, what do we go? We keep it here, from V we move to B in this direction. Just reverse the direction, it will be inward. So it will be inward, the direction of FM. Direction is, this is outward, is opposite to that direction, to the direction of V cross B. Simple. That is, if you are using for positive charge, we move, we keep the along with the direction of V, move towards B. So in this direction. But if it is a negative charge, what we will do, instead of this direction, reverse the direction like this. So it is inward. That is, the direction is inward direction. That's all. We need not to go for any complicated things. So we can simply this. We can make a simplified one. How we will make the simplified one? Simplified data means, for positive charge and negative charge, we will write a generalized form. Generalized form means, so direction of FM. Direction of magnetic force, as found out using the right hand palm rule, can be described as the sign of charge multiplied by direction of V cross B vector. V cross B is a vector, V is a vector, B is a vector, and V cross B is also a vector, because cross product of two vector is always a vector. So V cross will be, if V cross B in this direction and B cross B will be in the opposite direction. Same we use it for positive charge. For positive charge, what is this? This is equal to the direction of FM. Direction of magnetic force is equal to sign of the charge. Sign of the charge means it is a positive charge. That is plus Q. Plus Q. We will use the sign of the charge, that is plus, into V cross B. That is for negative charge. For negative charge, in direction of FM is equal to sign of the charge is negative, the direction of V cross B. See, V cross B, what is V cross B? This is V cross B in this direction. V cross B here in this figure, V to B, the extended, we are going from V to B. V to B, the extended finger is in this direction, that is outward. And minus of V cross B, it will be inward, because opposite to this, in this direction. So take the direction of V cross B, and for positive charge use the right hand palm rule. For negative charge, what you do, just reverse this direction. For what is the direction of this V cross B for the positive charge, just reverse its direction, that's all. So it means for positive charge of Q, the direction of magnetic force is equal to sign of the charge multiplied by the direction of V cross B, that is equal to positive of V cross B. And for negative charge, and this Fm, see, we have to note from the cross product properties, Fm vector is always, because A cross B vector is A vector, B vector, A cross B is the cross product of A vector and B vector, and A cross B will be always perpendicular to vector A and vector B. Same way, B cross A also a vector, exactly the opposite direction to A cross B, but also perpendicular to the plane containing A and B, and it will be perpendicular to vector A and vector B. So Fm, you can say Fm is always perpendicular to what? Here Fm means this vector is involved, always perpendicular to V cross B. V cross B means V to B this way, B to B downwards, but it is always, this is the plane, it is either this way or this way, it is perpendicular to the plane containing V vector and B vector. So for negative charge, only thing what we do, we put the sign and multiply it with the, multiplied with the same direction of V cross B, that's all, nothing else. So an Fm, that is negative charge direction of Fm is exactly opposite to positive charge direction. Positive charge direction is, this is scalar Fm, that is V cross B vector. So in this, for this negative charge we can write it as, for that positive charge, what is this? See, this is V. So we can say this is V vector and this is B vector, and this is the theta, and this is positive charge. So we are moving from the stretched or orienting the right hand fingers in the direction of V and move it towards V, so it is in the upward direction. So B cross V, you can say that it is parallel with, it means what? For negative charge, the direction of Fm for negative charge, the direction of vector, for positive charge, the direction of vector will be in this direction, as is the direction of V cross B. It means Fm, this is the direction of V cross B, and V cross B is the force is in this direction. It means cross product of V cross B is in this direction, and F for positive charge also in this direction. For negative charge, first point, for negative charge, Fm will be opposite direction. This is the same direction, means in the opposite direction to the V cross B vector. This you have to remember, it's a very simple rule. For negative charge, the direction for negative charge, the direction of Fm will be exactly in the direction opposite to the cross product of V cross B. For positive charge, the direction of Fm will be same as the direction of V cross B. Because here this is scalar, it has got nothing. It only increase the magnitude of the vector, either small or big, but the direction for V cross B, and for negative charge, Fm both will be in the opposite, Fm will be in the opposite direction, and V cross V, if it is in this direction, the direction of the magnetic force will be in this direction. This only we have to remember all about this right hand palm rule. F cross V, because we have to involve so many processes, because of it involves V cross B. Or we can simply write for positive charge, since Fm is a vector, is equal to scalar multiplied by a 2 cross multiplied by a 2 vector. Cross multiplied 2 vector, it means this vector and this both will, because V cross B, this is a scalar. So we need not to worry about it. Its direction and its direction both are same. And this direction, if V cross B is in this direction, Fm will be also in the same direction. So for positive charge, Fm is in this direction, it means V cross B in the same direction, both will be same for positive charge. For negative charge, Fm, see V cross B, vector V cross B, if it is in this direction, and this will be exactly, because only thing difference V cross B, first for whether it is negative charge or positive charge, you go with the right hand palm rule. First find out V cross B. If it is a positive charge, the direction is same, V cross B. If it is a negative charge, just reverse the direction. That will give them, find out this, and whether in the same direction, V cross B direction, it will be the same direction for positive charge, V cross for negative charge. You go find out this direction and reverse this direction, that gives the direction of magnetic force of this one. We have to remember this thing, A cross B vector is equal to negative of B cross A, same way. So its direction is in this direction or in this direction. If it is in this direction, B cross A will be, A cross B is equal to, B cross A will be, or we can write B cross A is equal to negative of A cross B. Both the case we use this one, because A cross B means something it comes, and B cross A is negative of this vector. Same way, V cross B direction is for magnetic force, same, both will be in the same direction, and this is for positive charge. For negative charge, take V cross B first. First to find out V cross B, you need not to go for B cross V, find out V cross B and reverse it. That is for the direction of Fm for negative charge. This is all about finding out the right hand palm rule. This palm rule is very handful in finding out the direction of magnetic field when a charged particle, maybe positive particle, positively charged, or maybe negative charged particle, but that is quite useful to find out its direction. It may be a positive or negative charged particle moving in the magnetic field.